On day 131 of the crisis, the international media made an understandable but potentially deadly decision. They packed up their cameras and left. Across the globe, news cycles pivoted to fresher, faster-paced events, leaving behind a volcano that had seemingly drifted back to sleep. The skies above Albay province were no longer choked by massive ash columns blocking out the sun, and the frantic mass evacuations felt like a distant memory from a safe distance. The mountain looked peaceful, blending quietly into the tropical landscape. But that peace is a geological lie. In that terrifying silence, the mountain hasn't stopped for a single second. It has simply changed its tactics, setting a perfect trap that combines unreleased subterranean pressure with a meteorological ticking time bomb. Welcome to the most dangerous, brutal phase of a volcanic crisis, the false calm before the storm. Over the past 24 hours, while the camera lenses were pointing elsewhere, the seismic network recorded a chilling reality. 6 consecutive times, massive slabs of lava precariously perched on the mountain's flanks collapsed under their own weight, sending cascading torrents of ash, toxic gas, and burning debris down the gullies. There were no supersonic explosions to warn the people below. The central monitoring computers registered 399 separate rockfall events, fracturing from the summit dome, alongside 30 volcanic tremors vibrating deep through the underground strata. A glowing red crater still hums against the night sky like an open wound, a visual reminder that the reactor far below remains wide open. Simultaneously, thick glowing magma continues to silently creep down 3 different gullies on 3 distinct faces of the mountain, like massive hoses slipping completely out of nature's control. The core anomaly of this disaster isn't a single earth-shattering eruption. It's the fact that these terrifying numbers, these signals of destruction, have become the new normal. The system isn't escalating into a spectacular blast, but it absolutely shows no signs of slowing down or cooling off. For a geological system to maintain this immense pressure for 4.5 months without completely tearing itself apart, fundamental scientific principles must be continuously operating kilometers beneath the Earth's crust. We typically associate earthquakes with the violent rupture of tectonic plates, massive slabs of rock grinding past each other after decades or centuries of built-up stress. However, the 51 volcanic earthquakes recorded in just a single day of observation stem from an entirely different mechanism operating on a microscopic timescale. They are the result of violent magma forcing its way through narrow fissures, the immense pressure of gas bubbles violently bursting in confined spaces, and the brittle rock structure of the mountain itself fracturing under the relentless upward push from the magma chamber below. These are usually small tremors under magnitude 3, and they won't topple buildings from a distance. But they leave a distinct acoustic fingerprint on the seismographs, an undeniable warning signal that this natural hydraulic system is being pushed to its absolute physical limits. Alongside these discrete fracturing shocks, the monitoring network detected 30 episodes of volcanic tremor. Unlike the sudden sharp snapping of a tectonic quake, a volcanic tremor is a continuous pulsating resonance, much like the sustained roar of a massive jet engine trapped underground. The physical mechanism behind this isn't breaking rock, but fluid dynamics. As viscous magma and highly pressurized gas are forced to navigate through tight, restricted conduits, they cause the surrounding rock layers to vibrate and resonate, similar to the physics of blowing wind across the mouth of an empty bottle. The fact that the system recorded these tremors lasting up to 45 minutes is not a fleeting anomaly or a data glitch. It is absolute proof of a sustained, relentless fluid flow, keeping the magma chamber alive for 3/4 of an hour at a time. This is the heartbeat of a magma supply system operating at maximum capacity, not the slow breathing of a mountain going to sleep. Meanwhile, on the surface, a far more dangerous and visible incubation process is unfolding right before our eyes. 399 rockfalls recorded in 24 hours means that every 3 minutes and 36 seconds, a chunk of material breaks off from the swelling summit dome and comes crashing down the slopes. The peak is continuously shedding material day and night, but the volume of fresh lava being pushed up from below is greater than what is being lost. This process creates a massive, precarious sediment bank suspended in midair. The extruded material piles up at the front of the lava flows in the 3 main gullies. Unable to advance further to relieve the pressure, it instead compresses and reinforces an immense dead weight on top of the existing structure. On one hand, the measured sulfur dioxide gas output has dropped to 1, 3, 4, 5 tons from a peak of over 7,000 tons, a signal that might lead the inexperienced to believe the magma supply is weakening. But on the other hand, the sheer volume of solid mass accumulating on those steep slopes is inching closer every minute to surpassing the mountain's mechanical load-bearing capacity. The slopes are fully loaded, stretched to their limits, and gravity is ruthlessly preparing to collect its due. The exact moment this system exceeds its breaking point won't be marked by a colossal explosion directed at the stratosphere, but by a horrifying, deadly collapse aimed straight at the ground. When the weight of the fresh lava exceeds the structural strength of the dome or the steep incline, it simply gives way. This collapse instantly triggers one of the most devastating physical phenomena in nature, a pyroclastic density current, or PDC. 6 PDC signals tore across the seismic charts in a single day of observation. To truly grasp the magnitude of this destructive shift, the approach we take requires peeling back the surface layers of ash to understand the violent physics underneath. A PDC is not a typical ash cloud that floats high into the air and gently snows down on rooftops. It is a super dense, churning mixture of superheated volcanic gas, razor-sharp fine ash, and burning rock fragments, ranging from millimeters to massive boulders across. The core temperature inside a PDC fluctuates from a minimum of 200 degrees Celsius, about the heat of a household oven, to a maximum exceeding 700 degrees. Any organic matter, whether vegetation or human flesh, unfortunate enough to come into direct contact with this infernal current will instantly ignite or carbonize in a matter of seconds. Inorganic materials like structural wood plastics and even window glass will soften, melt, or burst into brilliant flames. Even more terrifyingly, if anyone inhales the air at these extreme temperatures, the delicate lining of their lungs will be instantly and completely incinerated in a single breath. Beyond the incinerating heat, the speed and density are what truly make a PDC a perfect, inescapable killing machine. Because it is vastly denser than the surrounding air, the current doesn't rise. It aggressively hugs the terrain, weaving through canyons and spilling over ridges with the characteristics of a boiling fluid. It roars down the steep mountain slopes at velocities ranging from 60 to over 150 kilometers per hour, faster than any car speeding on a highway, and making outrunning it on foot a physical impossibility. By the time you spot the dark, billowing cloud rushing from the horizon, that searing wall of heat is already on top of you. It doesn't gently sweep over a house like normal ash. Its brutal kinetic energy shatters windows, violently breaches buildings, and fills every enclosed space until no oxygen remains. The 6 PDCs just recorded in the bulletin might only be small-scale flows traveling perhaps a few hundred meters before stopping. But they prove a grim reality. The collapse mechanism is still functioning perfectly. They act as warning shots from a colossal cannon fully loaded and aimed directly down the Basud, Bonga, and Misi gullies, the exact death corridors that point straight into the densely populated, thriving towns at the foot of the mountain. Looking down into the valleys below, we see a grim reality, the grueling war of attrition caused by an endlessly prolonged eruption. There is no single catastrophic casualty event making the front pages of international newspapers. Instead, there is a continuous, ruthless, and persistent erosion of human life, economic strength, and infrastructure. Nearly 200,000 people have been dragged into the vortex of this crisis, with over 5,000 still stranded, languishing in makeshift evacuation camps after 4.5 agonizing months. But for the luckier ones, permitted to return to their homes outside the 6-kilometer permanent danger zone, going back to square one does not mean finding peace. They are trapped deep in the cruel cleanup paradox of a volcano. Fundamentally, you cannot clean up a mess that is still relentlessly falling on your head. At first glance, layers of volcanic ash might seem soft, but they are actually a highly abrasive weapon. They are microscopic shards of pulverized rock and glass. When completely dry, a cubic meter of this ash weighs roughly 500 to 1,000 kilograms. But when the tropical rainy season arrives, and it inevitably will, this material absorbs water and instantly transforms into a thick, sludgy slurry weighing over 1,500 kilograms per cubic meter. This immense, dead weight is more than enough to snap, crush, and completely collapse residential roofs designed by engineers to withstand only standard tropical downpours. Simultaneously, in the murky air, microscopic PM 2.5 particles loaded with invisible crystalline silica penetrate deep into the lungs of hundreds of thousands of residents. Day by day, they cause irreversible damage, leading to chronic respiratory diseases like silicosis, turning every breath into a painful struggle. Expansive agricultural plantations, from rice paddies and abaca farms to coconut groves, are being choked beneath a blanket of gray ash. Livestock are dying slowly as their drinking water becomes tainted with sulfur. Transportation networks are paralyzed by zero visibility conditions and incredibly slick roads, while schools are forced to shut down time and time again, robbing thousands of children of their future. The 71.6 million pesos in relief aid might sound substantial, But when divided among nearly 200,000 people, bleeding economically every single day, it is nothing more than a drop in the ocean. This is a slow grinding financial and psychological exhaustion, a disaster with no clear end in sight. From these grueling daily realities on the ground, current meteorological models are forcing us to confront an even more catastrophic scenario. The prevailing working hypothesis among scientists is that the mountain has essentially finished its cruel part of the job. Over the last 131 days, it has patiently loaded the steep slopes and gully beds with millions of tons of loose sediment and fresh volcanic debris. Now, the most dangerous and deadly phase of the crisis no longer depends on the seismic tremors deep within the magma chamber. It rests entirely on the unpredictable judgment of the weather system. With meteorological agencies forecasting a sharp surge in tropical cyclone activity, a secondary disaster of devastating proportions is taking shape. Weather models indicate that if just one typhoon dumps over 100 millimeters of rain on the area, within 24 hours, that massive, waiting stockpile of sediment will instantly saturate, break its physical bonds, and slide. They will fuse together to form lahars, supercharged methyl mudflows with the thick consistency of wet concrete. These lahars will move with the devastating speed of an extreme flash flood, tearing down river valleys, ripping apart bridges, destroying drainage systems already clogged tight with ash, and completely burying the unfortunate villages lying in their path. The blood-stained history of this very region proves it. In 2006, the devastating typhoon Durian swept through, dumping 500 millimeters of rain and triggering massive lahars. The result was over 1,000 people buried alive in mud, not because the volcano shot directly at them, but because of the movement of mud and volcanic rock accumulated months prior. The massive deposits the volcano is patiently building on its slopes today have absolutely no expiration date, and this relentless accumulation creates a highly lethal time delay for an ultimate catastrophe. When we take a step back to view the full scope of this brutal picture, an event lasting over 130 days at a single volcano exposes a grand, undeniable truth. Geology and meteorology never operate in isolation. They are tightly interlocking gears in a massive grinding machine of nature. Downplaying the severity of a crisis or misjudging it simply due to the temporary absence of spectacular ash plumes on mainstream media is a mistake paid for in human lives. The mountain hasn't calmed down or gone to sleep, only the headlines have gone quiet and moved on to the next topic. The continuous seismic numbers, the daily triggers of PDCs, and the thousands of tons of sediment relentlessly added to the mountain's inventory are irrefutable proof that a disaster is never just a fleeting moment, but a prolonged, compounding chain reaction. To truly survive, adapt, and make life or death decisions in a world where the brutal extremes of nature increasingly collide and intertwine, we need far more than fleeting 2-minute news sound bites. We need rock-solid data, cold, deeply analytical precision, and a piercing vision that sees right through the surface phenomena that so often deceive the eye. That is exactly why we are here. If you want to keep tracking the complex evolution of this system and decode the harsh realities of our shifting planet without getting lost in empty hype, subscribe to American Sky Brief. We will continue to break down the science of the sky, uncover the hidden truths of the Earth, and bring you the raw facts about what is quietly building right beneath your feet.